I know. So I want to start by prefacing this with, though I got a bachelor's in biology, I am by no means a scientist or biologist or expert in body chemistry, but in the past year or two, in my process of preparing some athletes to try to make an Olympics, and preparing some of my athletes to compete at the collegiate level, I started to do a little bit of research into fatigue and how that impacts athletes in general, and then fatigue and how it affects cognition. Because we're dealing with athletes that not only have to move and perform, but also think while they move and perform, and fencing is really unique in that we're not just running a distance or throwing far. We have to actually react to stimuli as we compete. And being aware of how fatigue affects us, what fatigue is, how to better prepare our athletes for the stresses of competition. I think these are important things, and I think that they're not what fencing has focused on. How many of you guys, tell me here, anybody here know why we get tired? Why we start to fail? You're out on strip, and you're like, I'm done. We've all had this. I think we've either experienced or had a student feel like, I just can't fence anymore, I'm too tired. Any idea why?
A couple of reasons. The brain has gotten tired of making decisions. It's just the brain has worn out.
Okay.
2, they've run out of fuel for the muscles to burn. 3, the muscles are overheating.
Okay, overheated muscles and run out of fuel, got it, okay.
And
tired brain, yes.
well, basically, when touching the tired brain, basically when your cardio, or if you're doing something high cardio, you after a while, once your lungs isn't intaking enough oxygen, then your brain can't operate without oxygen. And basically, that's where the fatigue and mental, like, that's when you get hazy and like all that stuff.
Okay. Anybody else? Yeah. Okay. All right. There's a couple, some really interesting theories. A lot of us probably grew up with the idea that we cease to perform when a couple of signals go to our brain and a couple biological processes happen, okay? There are 2 stores of energy. There's liver glycogen, and that fuels our brain and all that good stuff. And then there's muscle glycogen, and that is the indirect fuel for ATP, and ATP is what directly makes our muscles work and fire and do stuff, okay? That's as exciting as I'm going to get with that, okay? I promise I'm not going to be more. The theory was, and then there's lactic acid. We've all talked a lot about lactic acid probably and soreness. The second idea of fatigue was that our bodies were producing so much lactic acid in our muscles that our body couldn't metabolize it fast enough to get it out, and our muscles failed. So that's called the catastrophic failure method of fatigue, or the catastrophic failure theory. And that was what we actually operated on as a theory of how our bodies work for years. And then some really smart people started to go, well, wait, that doesn't actually make sense. So the idea of that was, once you failed, you were done, right? So if your muscles have no more energy, they're finished. You've hit a wall. If there's so much lactic acid that your body can't process them, you've hit a wall. There's no more, you can't get better. But that didn't explain why elite runners could suddenly sprint to the end of a finish after they had hit maximum perceived exertion before that. There's something wrong with the theory. It's like something didn't make sense. So a team of researchers took cyclists first. And what they did was they took massive groups of cyclists and they had them cycle at a steady pace, elite athlete pace, over an hour. And over that time, they had to do 6 sprints as fast as they possibly could. And these guys were measured for heart rate, everything. The first sprints were really fast. And then the sprints started to fall off in speed. The muscles weren't firing as well. But invariably, so now, according to the first theory, that there's less energy in those muscles, they're not firing as well, there's too much lactic acid, that's why the times are falling. Except every single one of those athletes their speed peaked and either was their fastest sprint or faster in the sixth and final sprint. So what that meant was, from a research, and then they tested these guys for a ton of metabolic factors, but what it meant was, it wasn't possible. The original theory wasn't possible. They couldn't have run out of all their glycogen stores, and they couldn't have overloaded the body with lactic acid, because if they had, that sixth and final sprint could not possibly have been their fastest sprint. Just watch it. So then some neurologists started to do some actual look at what the brain was doing, and what they found out was that as the brain started to fatigue, there was actually less of the speed of the electrical impulses from the brain to the muscles was actually decreasing. And that was really interesting. So what they figured out, skipping a whole bunch of steps here, what they figured out is that the brain actually tells you, the brain remembers how much effort it takes to feel fatigue. It remembers maximum perceived exertion, and it starts to send your body feelings of fatigue and discomfort and feelings of weariness to stop your body from overheating, to stop your body from getting to the point where it doesn't have enough glycogen stores.
So it's a prevention.
Exactly. So what we were dealing with in terms of fatigue was our brains stopping us. Okay? A lot of people react to that with, well, oh, fatigue is actually an illusion. Well, I'm here to tell you, just because this comes from your brain, it doesn't make the fatigue any less real or any easier to overcome with willpower. Okay? But it does mean you should actually be training your brain to deal with very specific sets of stimuli if you want to perform well in competition. Okay? The single most important response to this concept of fatigue is to formulate and execute training plans that closely simulate the demands of your peak competition. Because you're training your brain to remember what it feels like to compete in a very specific way and in very specific demands. How many of you guys, in the 3 weeks leading up to competitions, have your fencers do pulls to these more than once? How many times?
We're kind of small, so we usually just once since like
One, okay, right? Ideally, and I know that this is tough, okay? I know that we have a sport which unique time and space demands, but ideally, in the 3 weeks leading up to a competition, we should be replicating the demands of competition as closely as we can. For an athlete's brain to really get used to the demands of 5-touch bouts in pools, waiting, then expending a lot of energy in a 15-touch bout, waiting. We should be replicating that as closely as we can in the 3 to 4 weeks up to a competition. Yes?
You want to make it slightly harder, like the old Olympic hockey team where the guys' practices were worse than any game?
No. Okay. Now this refers to tapering. In general, in the same 3 to 4 weeks before a competition, you want to increase the intensity of the work, but decrease the duration. So many of us, let's say in an open fencing night of 2 hours, we don't usually fence 2 hours straight in a competition, but you tend to have people taking their lesson and bouting at a relatively low intensity for a long period of time. What you actually want to be doing is decreasing the time, but increasing the intensity, okay? There's some scales that show that as you do this, as you're decreasing time but increasing intensity, injury rates lessen and performance increases in athletes. Now, again, these are largely measured on strength and speed athletes, so they're starting to research fencing, but if we try to move the information they've gained from strength and speed athletes into fencing, in general, as you taper down people tend to perform better and injure less. So in the 3 weeks up to a competition, ideally, you'd have a short, intense training session. So those 5-touch bouts, like, 6 5-touch bouts, go fence them. Maybe do 2 pools like that. And then 2 DEs or 3 DEs. Like so, and then get out the door. So mimicking the stressors of competition actually starts to train your brain to better react to the stressors of competition. So that leads now to cognition. And what we think as coaches, what we're dealing with on strength. So another study was done, and there's a couple PhD theses and other things that, just before I move on to that, so the guy who wrote an amazing book, and there's some articles which I'll forward to you guys, a guy named Matt Fitzgerald wrote Brain Training for Runners, and again, this was specifically for speed athletes, but his work and his research and what he put together in terms of fatigue and the brain is a pretty remarkable body of work, and I've taken a lot of my information from his essays and books, and like I said, I'll happily send you the essay that I have, the last essay I read, but this is who this should be credited to. Okay. When athletes are put under heavy physical stress, our brain performance actually lessens. So there's a theory that there are sort of 2 models of brain. The parts of your brain that handle like automatic stuff that we're used to. And any coach can tell you that by repetition, muscle repetition, we can remember certain parts of technique without our brains particularly thinking about it. Okay? Lots of athletic competition relies on this. Okay? And then there's sort of higher functions that are like thinking about tactics, thinking about the person in front of us, thinking about how we need to get ready for our next bout. So there's 2 sort of parts of the brain that are at work. There was a study done where they took a group of athletes and they performed about 60 minutes of work of varying intensity. And then they ran them through a battery of cognitive tests. As a result, they had increased response times during competitive cognitive vigilance tests where they had to really process pieces of information, decreased performance in complex visual discrimination tasks, a decrease in short-term memory. This is important for fencers. A decrease in short-term memory, tracking, and perceptual discrimination. So what does that mean for your athlete on strip?
They can't think anymore.
They can't think, and they can't necessarily remember everything you think they're remembering. So if you are working under the assumption that the athlete that you're talking to remembers that last pull out exactly, or goes on strip really remembering all the time, that may not be true. Because as we are under physical stress, our short-term memory is good. What we're tracking is good. Curious, how many of you guys think, how much time to recover from that deficit? So we have a sport where often we do a lot of physical activity, we rest a little, and we do it again. How much time to recover from that deficit? Anybody?
Yes,
Have any
about 10,
guesses?
15
What?
minutes. About 10, 15
10,
minutes.
15 minutes?
That's
Probably a couple hours.
Say at least an hour.
10 minutes? Okay. So the same group of athletes was tested 5 minutes after they exercised and then 30 minutes later. 30 minutes after, their short-term memory hadn't improved at all. So again, when you're talking to your athletes on strip, and you're under the assumption yes.
But this is under like maximum stress.
Not totally. It was it's high because they're doing some steady state and lower activity and then higher activity. It actually mimics fencing pretty well. Because if you think about it, we're kind of doing something and then. So it wasn't like to death. you know, I can give you the parameters they exercised at, but it was like 65% of VO2 max effort and perceived exertion. It wasn't like, so it wasn't like to complete death lying on the floor failure.
Regardless, I mean, this would be like a sliding scale anyway, right?
Exactly,
You know,
but-
so you're going to see effects at a lower level.
Right,
Maybe more
but
effects higher.
to assume, again, that after that 20 minutes between, or 6 or 10 minutes between pool bouts or DEs, or the 20 minutes between DEs, that your athlete really remembers, really gets it, and remembers what happened in that last bout when you say, you remember that action? Yeah, do that. That may not cut it, okay? So we're working under a whole bunch of assumptions that our athletes actually remember that what just happened to them, that they remember the actions that happened in front of them, that they can differentiate.
What I was going to ask was, was there anything in your data that suggests that visual recognition and stuff? So say if you recorded the previous bout and said, "Here, look."
No, that would there's no specific data, but remember, we're looking at someone who may not have processed things in the way that we as the coach looking off to the side process them, and they may not remember them. So giving them any stimuli to say, all right, look at this.
Okay.
And giving very specific feedback about what they should be doing helps us. Okay, as coaches. Saying, all right, go just do that thing you did. We've all, giving positive feedback. Again, not sitting and saying, don't do. That athlete may not actually be aware of what they are doing. Saying, do more of this. And I know people have talked a lot about the positive feedback versus negative feedback. But when you think about the fact that an athlete doesn't remember and isn't processing things in the way that they normally do when we give them a lesson or when they're relaxed, that really makes that idea of positive feedback much more crucial. Because to say, stop doing X to an athlete who may very well not be aware they're doing it has limited benefit to us. Say, do this. The athlete over there is doing this specific thing. This is how you need to react. And I'm not saying sit on the sideline feeding your athlete action after action. I think that's ridiculous. Athletes clearly have to make decisions and strip on their own. We can't fence for them. But we can